shows the effect of applying a scale factor to either the x values or the y values of a function. You can use this knowledge to help you sketch graphs. I'm going to use 3 examples to show you how this works. So in this first example, I've drawn y equals x cubed plus 2x squared plus 2x plus 1. Here it is in pink. Factorised, that is x plus 1 all multiplied by x squared plus x plus 1. So you can see that the roots are when x equals -1, and you can see from the graph that it should go through y equals 1, which it does. Okay, so let's have a look at what happens if we multiply the whole of this function of x by 2. Here it is drawn in green. Okay, and now let's have a look at what happens if we multiply the function of x by 0.5. Let's do that in blue. Here it is, the blue version there. The blue and green graphs are both vertical stretches of the original graph by the multiplied constant. This means that in the case of 2 times the function of x, and that's the green graph, all the y coordinates are doubled and it's stretched like this. In the case of 0.5 multiplied by the function of x, and that's the blue graph, all of the y coordinates are halved and the graph appears squashed. So if you have a graph that is multiplied by a constant, you now know how to adapt the original graph in order to sketch it. So example number 2, let's have a look what happens if you start off with the graph y equals x squared minus 9. Here it is, as it factorises to x plus 3 multiplied by x minus 3. We can see the roots are -3 and 3, and that it goes through -9 on the y-axis. So there it is. So what happens if you multiply all of the values of x within this equation by 2? Here it is drawn in green. And let's have a look what happens if you multiply all of the values of x within the equation by a half. Let's draw that in blue. They are both horizontal stretches of the original graph by 1 over the multiplied constant. So if we multiply all of the x values by a number greater than 1, it gets squashed in from a x point of view. If we multiply all of the values of x by a number less than 1, it gets more stretched out. So here's our third example, and it's a special case. Imagine we have our original graph drawn in pink again. That's that graph plotted. Imagine if we multiply that function of x by -1, we will get the green line just here on the graph. As you can see, this is a reflection in the x-axis. You can see the pink one and the green one. If we use our original graph and we multiply all of the values of x by -1, we can plot the blue line just here. So that graph is the blue line, and you can see in that case that this is a reflection in the y-axis. I hope this has helped. Thank you very much for watching.